Hey everybody, so hopefully 18.1 was easy. We're going to do 18.2, but before we do that, I do have a warm-up, so go ahead and try this. Alright, so here is the answers, so check your work. If you have any questions, don't forget you can join me on one of my Zoom sessions. Alright, 18.2 is now sine and cosine, so if you already understand tangent, sine and cosine is going to be really easy for you. Sine is the slope part, and cosine is the cut part, and then TOA we already did. So remember, O, H, and A are the same thing, opposite, hypotenuse, and adjacent. So we're doing the same thing, but this time with sine and cosine ratios. Alright, so copy down the title and the essential question. Some of you guys have noticed on your notes that you've been sending it to me, you're not copying down the title or the essential question. Make sure that you're copying it down. Alright, here is the ratio for cosine, so please copy this down. This time it's the adjacent leg, so A over the hypotenuse. So same idea, hypotenuse, if you're going based on A, the opposite leg would be CB, which means that the adjacent side would be AB. So same idea. Copy down cosine and copy down sine. Sine of the angle is equal to the opposite leg, so O over the hypotenuse. Copy this down. All right, example 1, I want you to copy down also. We're going to find sine and cosine of both angles, D and F. You never find sine and cosine of the right angle. That's impossible. So I'm going to start with angle D. So based on angle D, the hypotenuse isn't going to change. DF is a hypotenuse. It's opposite the right angle. Opposite of angle D would be EF. So this is O for opposite, which means that DE is my adjacent side. So sine of D, sine is so. So O over H, O is 8, and H is 17. Now if I do cosine of D, cosine is your ca. So it's A over H. A over H. And now I'm going to erase my A and H, sorry, my A and O, because now if I go based on angle F, the opposite side is now DE, which means this is my adjacent. The hypotenuse didn't change. So sine is O over H, so O over H, 15 over 17. And for cosine of angle F, it's A over H. So A, 8 over H, 17. And that's it for this one. Okay, you guys try this one. Pause the video. So here, for sine of x and cosine of x, the opposite angle of x, the opposite side of x is zy, which is 14.4. So originally I labeled this O. The H never changes, and then that means, I did the opposite of y. I did them both. Well, anyways, if you got this right, you did it correctly. I left the O and the A when I was doing sine and cosine of y. So opposite of y is xz, so side O. The hypotenuse is still xy opposite the right angle, which means that the adjacent side is here. So notice how sine of x and sine of y, the only thing that changed was the opposite value. So when you're going based on y, opposite is 7. If you're going based on x, opposite is 14.4. And same thing with the cosine of x and cosine of y. The hypotenuse didn't change. And notice the correlation here. All right, in a right triangle PQR with PR5, QR3, and a measure angle Q90, what are the values of sine P and cosine P? So what do? You draw a triangle. So I'm going to go ahead and draw a triangle. So I drew my right triangle. They did say the angle Q is 90, so I made sure this was 90. So PQR, they said PR is 5, QR is 3, and they said what are the values of sine P and cosine P? So luckily this one's for P. So opposite, so let's do hypotenuse, opposite the right angle, is h, root of 5. Opposite of angle P, which will be side O, opposite. And this is the adjacent side. So sine is, remember, OH, and cosine is AH. So sine of P is O, 3, over H, 5. And cosine P is A. I don't know the value for A, so it's just side PQ, because we don't know what it is, over H. Okay? Just practicing writing the ratios. Okay, now we're going to do trigonometric ratios of complementary angles. All it is that if this is theta, then this would be 90 minus theta. Why? Because this is already a right angle. Remember, triangles at interior angles add up to 180. So if this is 90, that means that between these two, they have to give you the other 90, because 90 plus 90 is 180. So if this one was, let's say, 50, then this angle would be 90 minus 50, which is 40. So that's all they mean here by the trigonometric ratios of complementary angles. So sine of A is equal to cosine B, cosine A is equal to sine B. I want you to write these down. And then therefore sine theta is equal to cosine of 90 minus theta, and cosine theta is equal to sine of 90 minus theta. That's pretty much what I just explained. Copy this down. All right, so here's the second example. That's a little tricky, but we're going to use the information that you just copied down from the previous slide. So given that sine of 38 degrees is equal to 0, or approximately 0.616, it says write the cosine of a complementary angle in terms of the sine of 38 degrees. Then find the cosine of the complementary angle. So it's asking you to do a lot. We're going to do it by parts. So I'm going to write sine theta is equal to cosine of 90 degrees minus theta. They gave us sine of 38, so our theta is 38. So sine of 38 degrees equals cosine of 90 minus, well, this is theta, so where theta is at, I'm going to write in 38. Now we get sine of 38 degrees is equal to cosine of 90 minus 38 is 52 degrees. So what does sine of 38 degrees equal? It equals 0.616. So that means that cosine of 52 degrees is approximately 0.616. Okay? That's how you do this one. Okay, B, same idea. This time we're going to use cosine. So cosine theta is equal to sine of 90 minus theta. Where did I get it from? Right here. And why? Because we're looking at in terms of cosine of 60 degrees. So cosine of 60 degrees, so this is my theta, is equal to sine of 90 minus, since we said theta is 60, then I'm going to plug in 60 in here. So cosine of 60 degrees is equal to, oops, when I typed this in, this should have been cosine, guys, sorry. Not sine, okay? Is equal to sine of, what's 90 minus 60? 30. So cosine of 60 is approximately 0.5. Again, this should not say sine, it should say cosine. So cosine of 60 is equal to 0.5. So this is the value for sine of 30 degrees. So my complementary angle is just 0.5. Sorry about that. Okay, you guys try this one. All right, so here's this one. I wrote sine theta of cosine 90 minus theta. And the reason why I did sine is because it says sine. So I use this one. The angle they're giving us is 45 degrees. So I wrote 45 here. That's theta. So over here I came to theta and I plugged in 45. We wrote sine 45, and 90 minus 45 is 45. Then sine of 45 is approximately 0.707. So cosine of 45 degrees is this value. So it's approximate. Okay, here's the next example. This lesson has 4 examples, so we're going to do this one, and then one more example, which is example 4. So for this one, pause it here so you can read the question. So again, we're going to use sine, so, or cosine, ka. We're not using TOA, which is what we did on either Tuesday or Wednesday, depending on when you watch the video. So I'm going to go based on the information given. So hypotenuse is 12 feet, right? Opposite the right angle. Across from angle A is the opposite value, which is the wall. And they're saying this is x, which means this is your adjacent side. So I want to find the height of the wall. So that means I have to use the O. Well, who has O? Not cosine. So I have to use sine. So sine of the angle, 11 degrees, is equal to the opposite value, which is x, that's the height of the wall, divided by the hypotenuse, which is 12. How do I solve for x? Well, the opposite of dividing by 12 is to multiply by 12. So I'm going to get x equals 12 times sine 11 if you use decimals as a calculator, which I'm using also. So after using decimals, I ended up getting 2.29. So that is my value for the height of the wall. So this is in feet. All right. Question B is asking us to find the distance y that the ramp extends in front of the wall. So now they want us to find y. Well, this value is the adjacent value. So if I go back to sine, cosine is ka. So ka, toa. I need to use the A. So cosine has A, sine doesn't. Sine has O and H, opposite over hypotenuse. So I'm going to use cosine of the angle. So 11 degrees is equal to the adjacent side, which is y, divided by the hypotenuse. And so same thing, instead of dividing by 12, I'm going to multiply by 12. And then my y value is going to be 12 times cosine of 11 degrees. And if I type this into decimals, which I'm doing right now, you end up getting 11.779. So I'm going to round this to 11.78, and this is going to be feet. So that is the length, there are the distance that the ramp has to extend from the front of the wall. Okay. Example 4 has 2 parts, A and B. So we're going to do this one together. This is the last example, so A and B. Says find the acute angle measures in triangle PQR to the nearest degree. So step 1 says write a trigonometric ratio for angle R. So angle R, I'm going to write in my values. Remember, H is hypotenuse, then opposite, and then the adjacent side. So the hypotenuse is 13. Based on angle R, the opposite side is 7, which means QR has to be the adjacent side. Now we only know O and H. We don't know anything about the adjacent side. So, ka, toa. I'm only going to go based on sine and cosine because this is the lesson for sine and cosine. So I can't use cosine because I don't know anything about the adjacent side. They didn't tell me it's x. They didn't tell me it was y. They didn't tell me anything. I just labeled the side as A, so I can't use him. So I'm stuck using sine. So sine of angle R is going to equal the opposite length. The opposite length is 7, right? Opposite of angle R, divided by the hypotenuse, which is across the right angle. So 7 over 13. So this is my first step. Okay, write and evaluate an inverse trigonometric ratio to find the measurement of angle R and the measurement of angle P. Well, I'm going to use what I got from part A. So sine R is equal to 7/13. Remember that based on module 18.1, they said that if you're ever finding or trying to find the measurement of an angle, to use the inverse function. So I want to get rid of sine. I just want R to be left, which is the angle measure. So the inverse of sine would be sine inverse. sine inverse. So to both of these sides, I will do sine inverse. So this sine will cancel out with the inverse and leave r. And so now I'm going to use a Desmos calculator to type this in. If you're not sure how to type it in, when you go to desmos.com, I'm typing it in as I speak. If you go to desmos.com, it is scientific, and you're going to go to function. On function, F-U-N-C, it tells you all the sine, cosine, sine inverse, etc. So sine inverse of 7 over 13 gives me a value of 32.5. I'm going to round this to the nearest hundredth for now. But I want to, it says to the nearest degree. So that means I'm going to say angle R is approximately 33 degrees. Now, if angle R is 33 degrees, I need to find the measure of angle P. I can find angle P since this is 90 and this is 33. How do I do that? I subtract them from 180. So 90 plus 33 is 123. So this will give me 57 degrees. So I don't have to write the trig function. If you want to, you can. So this is what I would do. Again, I should get 57. So let me write this down. So measurement of angle R is 33. Measurement of angle P is approximately 57 since I rendered angle R. So I'm going to show you guys that I'll still get the same answer if I use trig. I label my sides based on angle P. So remember, H doesn't change. He's across your right angle, but now this is my opposite side, which means this has to be my adjacent side. Now, I don't know anything about the opposite side, so I cannot use sine. I cannot use sine, so sine's out. And if I wanted to use tangent, I can't because I don't know anything about the O. So I'm stuck using cosine. So cosine of angle P is equal to the adjacent side, which is 7, divided by the hypotenuse, which is 13. Again, to get rid of cosine, because this is an angle I'm trying to find, I have to use the inverse function, and the inverse function is cosine inverse to both sides. Cosine and the inverse function cancel out, so you're left with P. And if I type this into Desmos, cosine inverse of 7/13, I end up getting 57.42, but I have to round this off to the nearest whole degree. So 57.4 rounds to 57, which is the same as me subtracting it from 180. So notice you get the same answer. All right, you guys try this one and see if you guys get it right. All right, if you got this right, the measurement of angle Y should have given you 53 after you round, which means the angle Z is 37. All I did was I used cosine because based on angle Y, they gave us the hypotenuse. They didn't give us the opposite value, but they did give us the adjacent. So I had to use A and H. And AH is cosine. Sine is OH. So he's out. Tangent is out. I'm not even worrying about that. But so I used cosine. So cosine of angle Y is equal to the A value, 14, divided by the H value, 23. Because I'm looking for the measurement of the angle, I have to get rid of cosine. The inverse is cosine inverse. So those two cancel, and then I do cosine inverse of this fraction. When I typed it into Desmos, it gave me 52.5, and I rounded this to 53. Then instead of doing another trig function, I did 180 minus 90 minus the angle I found, 53, which ends up giving me 143. When I subtract it, I get 37, which is a measurement of angle Z. So if you got it right, you got these two. All right, summary. Given the measures of an acute angle, so on the right triangle, the angles they gave you have to be acute. And the length of the hypotenuse, you can use the sine and cosine ratios to find the lengths of each leg. Given the length of the hypotenuse and the length of a leg, you can use their inverses to find the measure of each acute angle. All right, here is your assignment. Your assignments are due Monday of next week on April 6th, okay?